Okay, we may as well get started, and I will let people in through the lobby as they join, but we may as well get started. So welcome everyone to the NATA webinar on AS 3788, Pressure Equipment In-Service Inspection. Before we begin, I'd just like to acknowledge the traditional owners of the land and pay my respects to elders past, present and emerging. My name is Don Arnold, Deputy Sector Manager Sector at NATA, and I'll be hosting the webinar with John Garvey, an experienced technical assessor who will be presenting. We also have Rob Small, another experienced technical assessor who will be helping John with any question and answer sessions at the end of each slide. So please add your questions to the chat. If any questions that we don't get time to, we will endeavour to answer those later. If you could please try and keep your questions short so we don't run out of time, that would be appreciated. Any questions that we get that require long technical in-depth answers may take too long to answer in this webinar, so we'll try and answer these later if we get to them. Just to note everyone that we will be recording this webinar, and it will be available later on the NATA YouTube channel and on our social media for those who can't make it today. So there's no need to try and record this yourself. So without further ado, here is John Garvey to present the main changes to AS 3788. John, over to you.
Good morning, everybody, and thank you for your attendance. The changes in 3788 are many, and as I go through the slides, I think Don will move the slides one at a time, and I'll take you through the various changes. Some are controversial, a lot of debate as to the changes, but please be aware that these are not my changes. These are changes by the Standards Australia and the committee that was formed to bring about the changes. So if we could move on to the first slide, that would be great. So let's have a look at an overview. The changes were a revision of the text. There were a lot of errors and a lot of changes required. A lot of clarification was needed and a complete revision of the inspection management requirements. And of course, revision requirements included risk-based inspection, which was often misunderstood by many in the industry. Risk-based inspection by some people was a hazard and risk assessment, which was an occupational health and safety or a work health and safety requirement, which was not the case, and required a lot of data to be entered into software to be able to bring about a strategic approach to inspection on risk-based inspection processes. So a lot of clarification was required for repairs, modifications, alterations, and re-rating, and that has been done, and it's very helpful to inspectors, and we'll talk about that a lot more later on in the webinar. The consolidation of appendices was essential. There were far too many appendices, I think you'll agree, and I'll just compare that for you in a couple of minutes. Roles and responsibilities were changed. Some were deleted and others retained with more clarification on those roles. And of course, Standards Australia have changed their styling for the writing of standards, and so it was essential for Standards Australia to ensure that the redraft was in keeping with the Standards Australia style guide. And of course, there's been an update to reference documents because there's been a number of changes since 2006, and they have been incorporated into the standard. Next. New Zealand opted not to participate on this occasion, and they have agreed to adopt the Australian standard as a standard for New Zealand as well. So anybody operating in New Zealand will be using the Australian standard 3788 on its own, as opposed to a joint Australian-New Zealand standard. And of course, the scope has changed completely from design and manufacture, as well as standards 3873, 3892, and 3920, which you would possibly be familiar with. A big change came about with boilers, which include requirements for compliance to 2593. This had not been covered previously. Many did not carry out an inspection to 2593, which is the standard for the safety management of boilers. So critical functioning testing or testing devices for the boiler management is now covered by 2593 as part of the inspection process. Also, a controversial issue has arisen where the committee required a 4-yearly radiographic or ultrasonic testing for a Class 1 vessel for longitudinal and circumferential wells and tube plate furnace wells, as well as a full thickness survey of fire tube boilers specifically. And again, I would stress if people are not happy with that or wish to debate that, it should be brought to Standards Australia attention and perhaps the ME1 committee to review comments. Pipe has been brought in under 4041 and the ASME code 31 or B31.1 and B31.3, as well as API 620 tanks. These had been covered before, but it's in more detail on this occasion with this publication. Non-metallic pressure vessels, for example, you might have glass, fiberglass, or some other polytype construction of non-metallic pressure vessels are included, and that is important because they had not been covered before, and I'm not too sure that there's very many vessels out there of non-metallic type, but they are there. I used to inspect them myself, and I am familiar with some industries that do use these, particularly in water treatment and various other locations. In-service personnel qualifications, training and assessment is included, and there is a table in the standard, or two tables, 3.1 and 3.2, which have been included. This is new to the standard. Before it was only advisory, now it's become part of the standard. And of course, before anybody starts doing inspection work, they are typically to have at least 5 years experience in the manufacture of pressure equipment and or the inspection of pressure equipment. So as I mentioned in the last slide, there's an inclusion of roles and responsibilities. So they are for inspection bodies and owners in particular. Next slide. Now, if we compare the two standards, on the left-hand side, you will see the 2006 edition, which had 8 sections and 26 appendices. So that's quite an awful lot that had to be reduced. And on the right-hand side, you will see that we have now 9 sections, which is 1 extra compared to the previous standard, and we only have 4 appendices. So all the appendices have been incorporated, either been completely removed or have been incorporated into sections and the current appendices A to D. So I think you'll agree it's quite a significant change. Next slide. So if we look at asset integrity and the inspection requirements, So we're looking now in the new standard to design, manufacture, transport, installation, commissioning, and operational use. So it's been broken down into easy chunks for inspectors to be able to follow and ensure that the design, manufacture, etc., of the vessel is in compliant with design codes, design registration, manufacturing code and requirements. And also they must look at the transportation of pressure vessels so that there's no damage during transit, either by sea, road, or rail. And similarly for installation. These are critical times, as I think you'll agree, where there is a high risk of damage to pressure vessels, and inspectors are actually to identify that there has been or there has not been any damage during these particular periods. The commissioning inspection also is now has a definition and is required to be followed and supervised by the inspector. The inspectors are now required to consider operational use of pressure vessels, and that will include everything from repair, online maintenance, modification or alteration. Modifications and alterations are also a legislative requirement. So inspectors need to be fully aware of any changes to vessels. An inspector may not look at the same vessel year after year or every time period to the next, as many customers do inspect a shop. And so they may alter a pressure vessel, and an inspector needs to make sure that they are aware of that. Re-rating is another issue, which is clarified later on in the standard, and we will talk about that. But they need to be aware of re-rating a pressure vessel and how to do it. Analysis of failures and changes in performance should be covered by the inspectors, so they need to have a look at any events that may have occurred during the life of a pressure vessel. Again, they may not have a full history of the vessel from their own experience and will be totally reliant on documentation, perhaps, or word of mouth from other people in the workplace where pressure vessels have been involved in an incident. Inspectors also will need to look at remaining life. This was always there anyway, but it's quite detailed now and spelled out a lot more clearly. And of course, preservation of pressure equipment. For some industries that do have mothballing programs in place, they do need to be aware that inspectors should look at the process involved in the preservation of that equipment, whether it be temporary or long-term, to ensure that the equipment is still managed, observed, monitored in preparation for going back into service. Next slide. So the standard has actually spelled out that it requires a strategic approach to be taken in the inspection process. And this is explained in the standard, and it's made quite simple. And there is a table that will help inspectors to see where the strategy will work for them for the inspection at the time of inspection. We won't go into the table itself, but suffice to say that there are many stages where a pressure vessel will require inspection, and that is detailed in that table. Something that was not in the previous standard was alternate standards which can be used during the inspection process. For example, they might consider, I'm trying to think of the other standards such as, what is it, API, or perhaps British standards or something like that they may already be familiar with, or some may be using ASME if those inspectors who are authorized by ASME they may be able to use those standards in relation to the inspection of pressure equipment. ASME versus Australian standards is a controversial issue. Some fully understand the requirements and others are not quite so familiar. But if you are going to, or if anybody is going to inspect to an alternate standard, they will need to be fully aware of the requirements of that standard. And ASME is a big one in particular. Some inspectors have been trained to national board in the US for the inspection of pressure equipment and are able to carry out inspections to the ASME code. So there is a detailed flow chart, which is figure 2.1, which was developed to assist the inspector with the inspection flow process and is well worth looking at. Next slide. By the way, Don, did you want to take questions on the previous slide?
Yeah, we don't have any questions yet, so it's all good at the moment.
Okay. Inspection body responsibilities. There's been a number of changes compared to the previous standard of 2006, and the requirements to comply with 17020 has been removed. It was often overlooked by inspection bodies previously. Many lone operators or single business operators did not comply with the requirement to comply with 17020, and that has been removed. So what you will find now in the new standard of 24 is that many of the requirements in the standard, or compliance requirements, I should say, are based on 17020 requirements, and that will become very obvious. And of course, it's the early edition of 17020. I believe 17020 is currently under review, and a new publication is imminent. So that has been removed to make it easier. And I think Standards Australia don't see that they should be enforcing compliance with another standard. So that was part of the style of Standards Australia rewrite. So Section 8 brings all the documentation together for inspections, and that will include issuing statements of conformity for pressure equipment. That is, that it's safe to use or safe to continue in service, or unsatisfactory, unsafe, and we'll talk about that later. There is a requirement in relation to equipment that is not up to standard or not compliant. So the inspector is now required to verify repairs, alterations, modifications, etc., to the standard. So if something has occurred to an item of plant or pressure equipment, then the inspector is required to acknowledge and verify compliance following those activities with pressure equipment. That had not always been the case previously with everybody. It was with some, but not everybody. Now it's spelled out that it is required to be done. The inspection body is required to have an organization chart, so that will include everybody in the organization, that is inspections, as well as coordinators for inspections or any other person involved in the inspection process, such as specialized skills. That could be NDT, weld inspections, anybody else in the inspection process within the inspection body. Their duties are to be outlined in the organization. And of course, required competency and training needs for inspectors need to be identified. And there is the section, as I alluded to in an earlier slide, that the competency will need to be assessed. There is no body or certifying body, I should say, that is mandated in the standard. So there is a table that will identify the skills required for inspection, and that will be expected to be followed. The inspection management system is to be documented as per Section 8, where all the documentation requirements are located in the standard. And that makes it a lot easier to reference and to go to, rather than hunting around the whole standard to find out what the obligations are for the inspection body in relation to the inspection management process. Questions, Don?
Yes, actually. So we've got a question from Prem Kumar Panika. Appreciate clarification on the additional competency requirement of inspection of electrical switch gears by current ASIP inspectors.
Yes, that has been a big topic of discussion during the rewrite. The electrical equipment has been brought in to the inspection process. I was going to mention it later, but it doesn't matter. We can talk about it now. There is a need for inspectors to go through an educational process for electrical switchgear inspections. It is high risk, and there are a lot of issues associated with it, because this type of equipment is generally charged with an inert gas. And some of these gases are proprietary. They won't tell you. They are made to suppress arcing within the system where the switches are, so as to minimize the risk of a catastrophic failure due to arcing. So they're not going to tell you what the gas is in particular, but they will tell you if it's safe or not safe for inspectors. Now, I think it's fair to say that most of those types of equipment will be long-term use before inspection, due to the fact that there's not a lot of moving parts, there is no fluctuation, creating cyclic stresses. In other words, the pressure is continuous from day of charge to day of discharge. That would be one cycle of the equipment. And so there is not a need for very, very regular inspections, such as an air receiver or some other type of receiver that is oscillating in pressure cycles, either full cycles or part cycles. So it shouldn't be a big issue, but they will need to be trained, and they will need to understand the equipment before they endeavor doing inspections. And inspection techniques will also need to be considered, and that is taken into account in the new standard, which we will go through later on, whereby external inspection determining the internal condition can be used. Does that answer the question?
I think so, yeah.
Yep. Any other questions from that slide?
Yeah, thanks, John. Thank you. Bye.
Okay. Now, and we've gone through inspection. We've gone through this one. Next slide. Safety has been a big issue for the inspection process, not only legislative. You will notice in the standard, those of you who have already read it, but there is a very big focus on safety during inspection, which are largely legislative and have been brought into the standard. This time when the standard was reviewed, 2024, a number of regulators were involved and identified this as an issue that should be considered. And so Standards Australia have amended the standard to include quite a lot of safety. It was previously an appendix, as I've noted there, and now it is incorporated into the standard itself. And wording and clauses have changed, more in line with national legislative requirements. All across Australia, each jurisdiction has a lot of safety requirements that are very common to each state and territory. And so they've been brought into the standard. That makes it easier. It saves them having to go hunting through legislation to find out what their obligations are. And so they've put it into the standard. For example, they must conduct a risk assessment. It's loosely called a risk assessment. It is actually called a hazard and risk assessment legislatively, but standards have decided to call it just a risk assessment. And I think everybody understands that in this day and age. Confined spaces is mandatory. Before it was guidance material, and now it's a bit confusing with standard 24 edition due to the fact that it brings in Australia Standard 2865 in addition to the National Model Code of Practice for Confined Spaces. And in that, anybody who enters a confined space is required to be trained and assessed for the purpose of entering confined spaces. And besides, most industries now are fully aware of their obligations in this area, and they will be requesting evidence of training and assessment before people can enter confined spaces. But inspectors need to be aware, just in case they may accidentally, due to their normal practices, have omitted to tell the client that they are getting into a confined space as part of their inspection process. Hazard management is now required, and this, as I said earlier, is a legislative requirement anyway, and inspectors will be required to hazard manage the inspection. For example, there may be gases in a pressure vessel that they may need to ensure is managed, and they need to manage their own safety requirements around pressure vessels that would have that type of contaminated atmosphere inside the vessel. One example comes to mind, which is chrome copper arsenate, which pressure vessels use in curing wood in particular. So inspectors will need to make sure that that is managed and that any residual hazard is equally managed once the main hazards have been removed. The same with falling objects or protruding objects that may cause a hazard for the inspectors. It may mean having to disassemble boiler components, for example. In steam drums, they may have to have those removed to ensure their own safety. And of course, there is the requirement to conduct a job safety analysis. That term is a common one, but there are other terms meaning the same thing, and that would be acceptable under the standard. And of course, there is the obligation of inspectors to comply with the owner's obligations. So the owner may have, as many of you would be aware, permits to enter certain areas, isolation of pressure equipment, tagging out of equipment, and so on and so forth. Many use what they call a lock system, and there are others. And so inspectors will need to ensure that they comply with the owners, which is why at the beginning, when scoping out the work, inspectors will need to sit down with the inspectors. Sorry, I'll start again. The inspectors will need to sit down with the owners in the scoping exercise to determine what permits and isolations, etc., have been done, will be required to be done, and how the inspector can participate in the owner's safety management system. Any questions on that one?
Not so far. That all looks pretty good.
Okay, we'll move on. So now the standard has incorporated a new clause for the preparation of inspection while plant is offline, which is a good thing. It's new, but it has always been done, I think, by many inspectors, making sure that they know what is required in preparation of doing pressure equipment, getting it ready to go offline. Some don't do it, but that's the inspection body and the responsibility to ensure inspectors are carrying out the checks. Some equipment is quite complex and can present many risks to the inspector, and so it's essential that they do prepare in advance. Again, it's largely safety related, and so the obligation is to do the risk assessment, perhaps during that process of determining what to inspect, how to inspect, etc., and make sure that all parties involved, that is the owner, their staff, inspectors, or the inspection body and their staff, do a complete hazard and job safety analysis, hazard and risk assessment. So it's essential, and the standard spells this out, that a vessel is completely isolated from energy, atmosphere is safe, and all the hazards management. Very often in the hazard management process, there is what's known as residual risk, residual hazards, and these have to be managed. It's quite common with some larger pressure equipment that are adjacent to live equipment, and so it's important that the hazards associated with working with live equipment are considered. It can be very dangerous, and I'm sure I'm not telling you how to suck eggs here. Many of you will be aware of the risks, but unfortunately, sometimes people are not aware and they need to be made aware, and that's why it's important that all involved in the inspection, from owner staff and inspection body staff, do collaborate and ensure that the risks are appropriately managed, and the standard spells that out. All contents must be removed, drained, equipment cooled, dried, vented, etc. In other words, pressure equipment must be presented in a safe condition, so that inspectors can actually carry out their inspection properly and have full access without any risks from heat, wet surfaces, etc., etc., and also energy associated with the equipment. So no inadvertent entry of undesired contents will remain or come into the vessel during the inspection process. And again, confirmation is to be provided that the vessel is safe for inspection. So that'll be another tick box in the inspection process to make sure that the vessel has been declared safe, either by the inspection body or perhaps a combination of the inspection body and the owner. The environment, as I mentioned earlier, is required to be safe to enter, and that it has been tested. Very often that would be gas detection, atmosphere detection for oxygen levels, or the three common gas, poisonous, toxic gas, explosive gas, and oxygen deficiency. So inspectors will need to be aware of these issues as part of their training, either by the inspection body or in conjunction with the owner, to make sure that the vessel is safe to carry out the inspection. Questions?
We don't have any questions yet, but just a reminder to everyone, if anyone does have any questions, please feel free to drop it into the Q&A function there, and we'll try and get to them at the end of every slide. But as for now, there's no more questions.
Okay. Next one. Qualifications of inspection personnel has been completely rewritten. In the past, it was very loose, and now it is more detailed. And they will have training and experience in manufacture and inspection, or a combination of inspection with manufacture. This is a controversial point, because where are people going to come from, having received 5 years of experience, for example? I don't know, but that's an obligation that the inspection body is going to have to ensure personnel have got manufacturing and or inspection of equipment experience. Some people may bring them in and train them up, but that's something for an inspection body to determine. The required knowledge of inspectors is made clear in the standard. Before, that was just information. Now it is simplified and it's made very, very clear. And also that there will be training in the key knowledge areas. The standard requires that, and assessment to that knowledge. Tables are there to assist the assessment of inspectors and the knowledge that they require to be able to do their inspection. And of course, anybody who is doing welding or NDT examination, they will need to be qualified. That was always the case, but now the standard makes it very clear, because in some cases, I think there were people who were not educated, trained, or experienced in that area doing this type of work. Now it's a mandated requirement. And of course, the standard is saying that an inspector will have typically more than 5 years experience with pressure equipment. Again, I don't know where inspection bodies are going to find those people with 5 years experience, or how it's going to come about. But that is what the standard is requiring. Possibly a little controversial. Any questions?
No questions so far.
Okay, we'll move on. We're flying through today. Now, there is a new definition for commissioning inspection, and it is made very clear. It's a lot easier to follow. It also forms part of the inspection process. In the past, that was not necessarily the case, and inspectors were not involved in the actual commissioning process itself. Now they must be part of the commissioning inspection process. They must ensure that the plant is compliant with the design documentation and that the vessel has been marked accordingly. There are requirements in the design codes and 3788 for markings of pressure equipment. Many times inspectors were not ensuring that the documentation matched the equipment and that the markings equally were not on the vessels. So that is now mandated. So there's a whole new scope of inspection outlined in the section, and that will make it easier for inspectors to follow. The inspection verifies that there's no damage, as I mentioned at the beginning, from manufacturing, transport, and installation. And these are high-risk areas where equipment can get damaged whilst in manufacturing, transit, and the installation process. So the inspector now needs to ensure that that is ticked off, that they have checked, and that there is no damage during these processes. And again, all documentation for the vessel is to be in keeping with the new Section 8 of 3788, which is quite detailed, and inspectors need to be fully aware of all documentation associated with pressure equipment. So the installation is required. This would be part of the commissioning process, that it is correct, that all the pipework associated with the vessel, everything to do with the safe operation of the vessel is confirmed to be correct. and it includes the inspector supervising all the pressure tests. Obviously, from the installation, there's no need to go to full test pressure unless the pressure vessel has been through a repair process at the time of installation. So pressures would be proof tests to ensure the integrity of a vessel in some cases, not all cases. So any testing that is done will be supervised by the inspector to ensure compliance. Questions?
Yes, we actually have a question from Sadipta Banerjee. Will ASIP certification ensure that 5 years experience requirement is met?
That's a very good question. If the holder of the certificate has 5 years of experience, then it is being met. If they don't have 5 years of experience, I would suggest it probably does not meet the requirement of 3788. However, they may have a combination of experience already in inspection, combined with manufacturing and other areas of pressure vessel work that would accumulatively make it 5 years. I can't answer it directly, but that's the only way I can see I can answer that question for you adequately.
Okay, I'm just putting that answer into chat along with some spelling corrections because it's not, mine isn't very good today. Okay, next slide.
Inspection during service life. Well, that is the in-service inspection. So it's a whole new section, which has been, well, it's a whole revised section, put it that way. It includes all the planning and selection of the strategy for in-service inspection. And again, location and methodology has to be considered for the inspection. There are many, the new standard does allow for different techniques to be incorporated into the inspection process, such as I said earlier, that is using alternate standards, techniques which are called non-intrusive for internal inspection, which must be equivalent to a visual inspection. In some cases, we now have inspectors using drones as part of the inspection process. And so that needs to be equivalent to visual inspection. Again, the equipment that is used must be adequate to ensure that the inspection is equivalent to a visual if they were to do it with the naked eye. So the standard has opened up this, which previously it didn't spell it out, whereas now it does. It doesn't go into all the detail, obviously, because there are many different ways of doing things. There's details now provided for internal and external extended inspections, what's allowed and what is not allowed. In the past, there was nothing to help the inspector determine whether it was okay to inspect in a particular way to extend these inspections. Now it does. And the inspector would be well advised to follow and check off that they have complied with 3788 in this particular area. Otherwise, it could be deemed that the inspection is or extended period is not acceptable. So be very careful in this area. It's always been controversial. There was inadequate advice to inspectors through the standard. Now it details it. Deferred inspections are made clear, as I say, and it's always been the case that they were allowed to defer inspections to 90 days. That hasn't changed. It was always the case. But it's how the extension is done by inspectors that was controversial and had not been adequately identified to the inspectors how to comply with that. There's now also a new section in the standard for special cases. This is where vessels may be lined, they're of advanced design, and have secondary containment. That has been spelled out in detail and gives very, very good guidance to the inspectors as to how to deal with those inspections, which is very good, and I quite enjoyed reading that section myself. Questions?
Yes, we have a question from Andrew McGregor. Please confirm that NII can be used for first in-service inspection as per clause 4.4.2. Slight confusion with clause 4.3.4a, noting HOIS RP 103 Appendix 3 has detail on NII for FISI.
That is a big question. I would approach that with great caution, bearing in mind that a first inspection is a critical inspection, in my opinion, and that is only my opinion, due to the fact that there are a lot of unknowns where the equipment has been in service since the commissioning inspection to the first in-service inspection. So I would suggest that anybody who would consider non-intrusive approach that with caution. In the previous standard, it was always understood that at the time of writing of the previous standard, that there would always be a physical all area inspection at the first inspection of pressure equipment following the commissioning inspection, because of these unknowns. And after, I think it was, you had to have a minimum of what they called 2 periodic inspections, then the inspection process could be altered based on the history and the knowledge of the first 2 inspections of the pressure equipment. So I would suggest that the NII for the first inspection be approached with great caution, and that sufficient, if they are to proceed with NII for the first inspection, that it is adequately covered to ensure that the inspection is complete and the integrity of the equipment is assured at that inspection. So that's the only way I can answer that in the absence of the standard clarifying it. But what can be done is if anybody identifies an issue with the standard, they should notify Standards Australia via the ME1 or 001 committee, and that information is looked at for clarification purposes. And there's a lot of good expertise on the committee, and I'm sure they can give a better qualified answer to that than perhaps what I can. But that's my methodology of approach, is to be very cautious to ensure that the NII is verifiable, that the integrity of the equipment is maintained.
Okay, that's that question. No more so far, so I'll go on to the next slide.
Okay, inspections are now called time-based inspection intervals. That used to be what was known as periodic inspection. And table 4.1 for time intervals is outlined, which was the same as before, except that they call them periodic inspections. There's not a lot of great difference in the terminology, but it's good to be aware of it. It also, and was the case previously, considerations of vessels in similar service, series or parallel, they've now been clarified a bit more, and that is a good thing, I think, because there were inspectors who were a little confused by some of the possibilities of determining the condition of a vessel using a sample. I can't say much more about it. It's similar to what was there before, but it has been improved in the standard for clarification. What was not included in the previous edition was consideration to excursions outside design operation. So that is a critical issue. We've had a number of pressure vessels that have operated outside design specifications, particularly for pressure and temperature, and inspectors have just automatically been unaware because nobody's told them. Now the standard, because as I mentioned in a slide earlier, that the inspectors need to take into account the operating conditions of a vessel and events associated with the operating of a vessel. So where an excursion has been identified either through pressure or temperature or perhaps vibration or some other aspect associated with the vessel, it may have been accidentally used in a service that it shouldn't be. I've come across that myself, where vessels have been used for a purpose for which they were not designed. And so the inspector needs to be aware of these things and carry out their inspection accordingly with that knowledge of the excursion outside design parameters. Operating conditions of equipment are to be considered for time intervals, so an inspector may decide to reduce inspection interval, time-based intervals, or they may extend, which is allowed in the standard as well. So the inspector needs to consider all these things, which is spelled out a little bit better than what it was previously. You will notice from table 4.1 in the 2006 edition, they were quite extensive, and now they have been greatly reduced. And I would advise anybody using the 2024 edition that you do consider the notes from the 2006 edition, because they were educational and they were helpful, but now they no longer exist. But you can use 2006 as a reference for information that may not be available in the 2024 edition. And again, all the sections associated with the inspection have been made clearer for the inspection process. Can't spell it out any better than that. It's very, very helpful. And I'm sure if we have conversation later on, we may hear some experience of those who have gone through the 2024 edition of the standard and how they find it for clarity. Any questions?
Not so far, so we can keep going.
Okay. Risk-based inspection, which I alluded to earlier, was often misunderstood, misinterpreted, and misused. And the committee recognized that this was a big issue. And so they've made the area or RBI much more clear. It's completely rewritten and expanded and with new sections. And again, RBI cannot be used in lieu of the commissioning inspection. And that is something that I had come across myself, where misuse of the RBI process was used at the commissioning process and little inspection was done. It was poorly managed, put it that way. And that was the fault of the standard, in that it didn't make it clear enough to inspectors as to how to go about doing RBI. The RBI system or methodology must be documented. So anybody who is going to be engaged in using RBI, excuse me, must have the system documented and follow that process. Again, competent persons are required to conduct RBI. There's a lot of software involved, and they do need to be able to do the calculations and enter the correct data into the system to be able to conduct the RBI. And very often, from my experience, I've found that people who do use RBI do incorporate time period inspections to verify the RBI process. And in fact, it was very lucky in a number of occasions that they had done that, because the RBI didn't cover every aspect of the equipment, whereas visual inspection did, and issues had been identified to do two things. One was to verify that the RBI process was functioning, and to identify where it was not functioning very well. And so a visual inspection helped with that process during RBI. So RBI now requires management of change. That's not a term that many inspectors would be familiar with. An example of that would be where pressure equipment is using a particular media, and they've been using it for quite a period of time, and then they change that media, which is a difficult chemical composition, to what had been previously involved with the equipment. So what has to happen when there is a change in media in a pressure vessel? The effects of that change need to be fully understood, and all downstream users of the equipment need to be made aware of the changes and the effects of those changes. It could be in gaseous form, or it could be in liquid form. I'm thinking more in the bigger corporations that use equipment for oil and gas, or other processes where there is a possibility of changes in the operation of the equipment as part of the RBI process. I think it's, to most people, it would be self-explanatory, but I think a lot of inspectors are going to have to be made aware of what it means. It can have disastrous consequences if it's not managed properly. The probability of failure for various aspects of the equipment must be fully understood, and that would take into account quite a number of aspects of the operation of pressure equipment, from environmental use of the equipment that could bring about failure, its location, its installation, a whole range of different aspects of the equipment. Inspectors are going to have to be aware of that. That is, those who are engaged in the RBI process, to ensure that they fully understand the probability of failure. And of course, the consequences of failure must be understood. And again, it's largely in the bigger industries where this is critical. It won't be so much so for the smaller operators with their air receivers and various other small receivers around the place. However, inspectors would be best advised to be aware of consequences of failure in all situations, be it boilers or pressure vessels. Questions?
Yes, we have a question from Babulal, who's asked, do persons conducting RBI need to possess any certification like API 580?
Good question. It doesn't spell that out in the standard. All it does say is that they need to be competent, and the definition of the competent person is someone who is educated, trained, and or experienced in the work that they will be doing. It has been my experience that most people doing RBI at the soft end of the job are qualified engineers, generally mechanical engineers or chemical engineers, who have been trained in the RBI process. And then people who go out into the field to collect data are generally either NDT qualified or they are inspector qualified, such as ASIP or other alternate qualifications associated. But there is nothing to say that they have to have API or ASIP for carrying out those inspections. Anyone who does do inspection work must be educated, trained, and or experienced in the work that they are doing. That's a combination of legislative requirement and also AS 3788.
Okay, no more questions so far, so we'll go on to the next slide.
Pressure relief devices, big issue. This part has been rewritten. There are new sections, and the old sections, which were in the 2006 edition, have been brought in and made clearer. It allows for in situ testing, which is a little bit of a contradiction because later on they say steam valves in particular will be tested in situ and with conditions as long as approved by a competent person. So yeah, I'm a bit confused myself on that one. On one hand, they say in situ, and then they're suggesting that it can be other than in situ. Anyway, documentation is required for all devices. So there are compliance requirements for pressure relief devices. When we're referring to pressure relief devices, we're talking about pressure relief valves, safety valves, and bursting discs or rupture discs as well. So the inspector needs to ensure that documentation confirms the compliance of the devices and that they record that compliance documentation. Lifting gear on valves where they are fitted must be fully supported and functional. So not every pressure relief valve will have lifting gear. It used to be mandatory on boiler safety valves or steam safety valves that they did have lifting gear, or what was commonly known in the industry years ago as easing gear, so that the valves could be lifted remotely and the steam relieved from the boiler or accumulator. Boiler safety valves must be tested in situ unless documented alternate method suitable. So in the past, there were providers who would test valves on the bench and use a compensation table for the temperatures associated with the valve so that they could set them and then put them on the boiler and they would stay there without being tested. The standard is now saying that steam safety valves will be tested in situ. So whilst they may be set on the bench, they will be installed and tested in situ. And unless there is an alternate method suitable. Now, what can be done is what is commonly known as the Trevi test. That still remains, and that would be a suitable alternate method for testing of boiler safety valves, where the lift is determined, the reseating of the valve is determined, and the accumulation on a new boiler as part of the commissioning, there would be an accumulation test. So assuming the same valve is in use at the first in service or second or third in service, then that valve, it should be okay to be Trevi tested. Yeah, I can't say much more about that. It's a controversial issue. And in addition, all the valves must be vented safely to prevent damage to equipment or injuries to persons. That was not always the case, unfortunately, and some people have been injured from the discharge of pressure relief valves or safety valves. Now it's mandatory that they must be vented safely to prevent damage and injuries. Questions?
Yes, we have a question from George Brown. Does the boiler safety valves accumulation testing need to be witnessed by the ASIP inspector?
I would suggest yes, because the inspector is going to certify that the pressure relief device is compliant, and therefore they will need to ensure that the accumulation does not exceed what is required in the standard. Where one or more valves are installed, they need to ensure that the accumulation, I think it's 104% and 106% in the event of one valve. I stand to be corrected, but that is the case. Yes, the inspector needs to witness.
Okay, we don't have any additional questions, so I'll go to the next slide. Oops, sorry. We do actually have one new question just now. Also from George Brown, a follow-up question. Does this include all the boiler management system testing?
Yes, it does. The inspector has an obligation now to carry out a full inspection on all devices on a boiler for compliance to the Australian standard 2593, which is the safety management of boilers. They must go through the entire standard relevant to the boiler that they are inspecting.
Okay, no more questions for now, so I will go to the, we've got this next slide here.
Yep. So this has been rewritten and is made clearer, which is very good. Quick actuating closures, which include interlocks and swing bolt doors, has been expanded, and it's much, much better than what it had been before. And inspectors are best to study it in detail. This is an area where I used to find a lot of non-compliance following inspections, that there was no checking. There will be an obligation also that the inspectors to do critical function testing on these items of equipment with quick actuating closures that comply with AS 1210. And there is the obligation to ensure that pressure cannot be entered into the equipment whilst doors are open. And equally, that doors cannot be opened whilst the equipment is under pressure. This has been a big problem for regulators in the past, where quick actuating closures were not compliant because the equipment, when it was sold to them, didn't have interlocks installed, and so on. It's a big issue for a lot of people, including inspectors as well as the regulators. So there is more information now in the standard. It's been expanded, and it's educational for the inspectors to ensure they fully understand this equipment before doing their inspections and during critical function testing. Instrumentation and controls are now, as I say, required testing, so they will need to understand the equipment a lot better than what they have in the past. Not everybody is included in that. Bear with me, it is a broad sweeping statement, but there is a lack of knowledge on a lot of this equipment. The critical functioning test of the equipment is there to ensure the safety of the equipment and the personnel that will operate the equipment. There is equipment out there designed and compliant with the ASME code, which is different to pressure equipment, quick actuating closures, which are compliant with AS 1210. And the two differences need to be understood by inspectors before doing their inspection. This could be an educational gap for inspectors, and this is a good opportunity for them to catch up and learn a lot more about this type of equipment in use. Vacuum insulated vessels have a vacuum reading recorded every 6 years, both at the commissioning, which will be a baseline data, and then every 6 years thereafter, they will be required to re-examine the vacuum. That could be a bit controversial because generally this type of equipment is sealed up. I can already hear in my head a lot of people saying this is going to be a problem. Well, that's what the standard requires. And it's not a bad thing because I think vacuum has been lost or reduced. Air ingress from atmosphere has caused inefficiency in these types of vessels, but that's for the inspection industry to come to terms with. Piping has been difficult to inspect, and now they are saying in the standard that representative samples can be used as reference. That's a difficult issue. Buried piping in particular has always been difficult. Not every pipe can be pigged, for example, for inspection using intelligent pigs. And so it's going to be a little difficult to inspect some of that. And now what they are saying is reference samples can be used as indicative of the whole of the system, perhaps. But that's something that an inspection body will need to come to terms with as to how they will have a suitable representative sample for inspection purposes. There is good inspection guidance now in Appendix C and is informative in this area as well, which should be helpful. Any questions on that?
We've actually got another question on the previous slide from Prem Kumar Panika, who's asked, in case the PSV is tested by third party, does it mean that it needs to be witnessed by ASIP inspector?
It will, I would suggest yes, the inspector needs to do an in situ test, but it will depend on where the valve is installed, what it's installed on. It's too broad to be able to give a precise answer. I don't have all the details of where the imaginative valve is located, but simply put, the answer would be yes. The inspector has an obligation to ensure the effectiveness of that pressure relief device.
Okay, that's all the questions for now. So I'll go to the next slide. Oh, lunch break. Let's keep going.
We're ahead of ourselves. Okay. Assessment of pressure equipment integrity. The section of the standard is rewritten and shortened, which is quite interesting. And again, focus of this section is in relation to the fitness for service of the equipment that the inspector is looking at. That is what they are primarily focused on, is to ensure that the integrity of the equipment is suitable to be able to go into service, either from commissioning inspection or an in-service inspection, that everything about that piece of equipment is okay to go into service. Also, the investigation of defects. Some defects are not brought to the attention of the inspector, and others, inspectors will identify defects, and so there needs to be a full investigation by the inspector to ensure the integrity of the vessel following the detection of defects. And of course, the section also includes assessment for remaining life, repair and defects in particular. So a lot of vessels out there have not been assessed for remaining life, particularly those in high-risk industries, together with critical functioning of pressure vessels. I can't say a lot more. It's just there needs to be more focus on remaining life for aged equipment, high-use equipment that have gone through excessive or high oscillating cycles, and any repairs and defects that a vessel has gone through needs to be fully assessed at inspections to ensure the integrity of the equipment. I think it speaks for itself, quite frankly, but the standard has made this area a bit easier to read than what it was before, even though it's been shortened. Any questions?
Yes, so Babulao has asked a question on a previous slide. Further to a previous slide with regard to verification of repairs and modifications by the inspector, does this mean only documentation verification or in fact witnessing of repairs and modification?
A combination of all of the above. The inspector needs to see documentation associated with repair. For example, they will be checking that there has been a partial MDR, Manufacturer's Data Report, issued, that the materials, the weld procedures, qualification of welds, all that sort of thing where a repair has been carried out, the inspector needs to ensure that it is compliant for the purposes of 3788. Now, as part of that, they may have engaged a third-party weld inspector. The weld inspector's report will be part of the pressure vessel inspector's report to ensure that repair has been verified as compliant by way of welding, any NDT, that the material is suitable, that the weld procedure is suitable and qualified. What more can I say? Yes, the inspector has an obligation to verify all of that. That was always the case, I might add. That was always there. It's just that it hasn't been fully understood.
Okay, that's it for the questions so far, so I'll go to the next slide.
Okay, now we're talking about repairs again. It's been rewritten and in more detail, and it's made clearer. So this should help the last question find the answers that they're looking for. And of course, focus is on remediation of equipment. Equipment must be brought back to original condition to ensure its compliance with the original design. So the selection of material, etc., as I've just discussed, weld procedures and so on and so forth, it must be in keeping with the design code and that the equipment is returned to its original state. This may have difficulty for some people where a vessel is aged and was designed to a much earlier edition of the current design code. For example, AS 1210 or 1228 or what used to be known as 1797 for boilers. So it's all about getting the vessel back to its original condition and remediating the equipment and making sure the integrity of the equipment is fit for service. It goes into the retrospective considerations, methods of repair and re-rating of equipment. So all what I've just mentioned is included in the standard, and an inspector would be well advised to educate themselves on all these different aspects of repairs. Weld information and use of competent persons Again, I did mention that earlier. Anybody doing welding inspection, anyone doing welding to a procedure must be qualified and so on and so forth. And the inspector has an obligation to ensure that that has happened. If it has not happened, then it's non-compliant. Interim repairs were never considered before. Now they are. There are techniques whereby a temporary repair can be used, but it must be safe. So the inspectors need to ensure that they consider carefully or engage competent persons who will understand the interim repair, which can be used before a permanent repair is carried out on the equipment under consideration. I'm thinking where I have myself come across interim repairs that were not compliant and were rather dangerous, and equipment was put out of service until an alternate interim repair was carried out before the permanent repair was done. This is for both boilers and for pressure vessels. There are techniques which are not often understood by inspectors, but if they don't understand them, they should be engaging competent people in the area of repairs to ensure that whatever is done in the interim period is suitable. It's dangerous otherwise. Re-rating of equipment is expanded, and there are a lot of good details in relation to that, and it will help the inspector to be able to understand what's required in the re-rating process for re-rating equipment. Some information on the replacement and disposal of equipment is in a new subsection. This had not been there before, and this ensures the safe disposal of equipment and advice to inspectors to ensure that equipment is treated appropriately so it does not find its way back into service, which could be very dangerous and unfortunately has been done in the past. And the standard now makes it a little more clear and easier to understand. Any questions?
Not for this slide, so we will continue to the next one.
Investigation of damage, deterioration, and failures. This is always a popular one. It's completely rewritten and includes a regulatory obligation requirement. It's definitely made clear and provides better direction to inspectors for investigations. The regulators for many years have had a problem whereby owners of pressure equipment have not notified the regulator, and the inspector has been called in to check over the equipment without the regulator's knowledge of the damage. Okay, this is a brand new section and has brought all the documentation into this section. It's a very, very good read and very clear and very informative to inspection bodies as well as the inspectors. It includes need for equipment files. This really is an owner's obligation. It's actually a legislative requirement, but now the standard is saying owners, you need to keep a file on your pressure equipment. And obviously it specifies hazard level A, B, and C. Although the better registers that I have seen myself, they actually go down to hazard level D, and in some cases they go to E. Now, D is good from the point of view there is the obligation across Australia for hazard level D equipment to be design registered, and that's why a lot of the better businesses do keep a register for hazard level D equipment to ensure that anytime they bring hazard level D equipment into use, that they can be assured that it has design documentation associated with that equipment. But it's up to each owner of equipment to determine how they will maintain the register. I do know some inspection bodies maintain the register for their clients, but it belongs to the client, and they need to make sure that they have hazard level A, B, and C included regardless. The minimum details for inspection reports are outlined, and the need for statement of conformity is included. That used to be a mandated requirement, or still is a mandated requirement under ISO 17020, which includes the need for recording equipment history in a subclause, which is in 3788. So it's very helpful to the inspector to be able to access the history of equipment, the inspection history, repair history, or any other type of history associated with the equipment. And particularly in some cases, that's going to be critical for the management of change, where equipment which can be used with different media is included. So I would advise owners who are through the inspectors to advise the owners to make sure that they record any changes in operation of the equipment, bearing in mind that it's an inspector's obligation to check on that history to ensure that they're inspecting knowing that there was a different media in use, perhaps from the last time they inspected, or if they haven't inspected it before, that it has a history of change of media in use in the equipment. As some media can be corrosive, toxic, or otherwise, and so the inspectors need to be aware of that. So it's very helpful to have that pressure equipment file with the history of the use of that equipment. This is more the case, I think, in the bigger industries, not so much for perhaps the smaller businesses that are operating small receivers around the place. The inspector needs to outline any unsafe condition that they've identified, bearing in mind that the standard is now highly focused on safety, and the condition of the equipment being unsafe needs to be remediated to a safe condition, and the inspector to advise as to what is unsafe so that it can be addressed and fixed by the owner. It may be a repair that's necessary, or it may be an operation of the equipment. It's not unusual, I might add, to discover pressure equipment that is used in a service for which it was not originally designed. And so the inspector needs to advise the owner what to do where the owner has either inadvertently, through accident or otherwise, used the equipment for a service other than which the equipment was originally designed. And that is mentioned earlier in this webinar, where the equipment must comply with design requirements. Excuse me. The commissioning inspection is different and is covered in clause 3.2, which we referred to earlier. The commissioning inspection is a mandated inspection for the inspector to witness and ensure that everything is compliant following transport, installation, and now the commissioning. There is clear direction on identification and marking equipment, and includes any regulatory requirements for marking pressure equipment. Very often equipment has been brought into the country that has not been compliant, but the inspector still inspects it anyway. So I think the standard will make it more clear to inspectors to be very cautious about inspecting equipment to make sure that it is marked accordingly and that the documentation matches the equipment and the markings. A lot of really good inspectors out there pick up on these things, and they don't actually inspect that equipment. They leave it alone, bearing in mind they're buying into a liability not of their own making. Inadequate marking on equipment is included, so there's details about that, and it gives very good direction for inspectors to follow. I found that very helpful, and it was something that I used to deal with quite a lot and advise inspectors. But I think inspectors are now getting more savvy and being very cautious about dealing with equipment that is inadequately marked, has no documentation, etc. It's a big liability. The equipment file contents for owners is detailed and ensures equipment is safe to use and continues while remaining in service. Owners have an obligation now to ensure that the equipment is safe to use. And what they are going to do is put that on to the inspector and say, I have an obligation to ensure the equipment is safe to use. I need documentation from you that says the equipment is safe to use. Bit of a controversial issue, but it's something that inspectors and owners have to come to terms with, as it is a regulatory requirement. Missing documentation and nameplates is addressed with very clear directions, which was very good to see. And it's something when I was a regulator, I used to address quite a lot. Very often equipment did not have any documentation whatsoever. Nameplates were buried under insulation or didn't exist whatsoever, and owners wanted to use the equipment. That is made much more clear now in the standard and is very, very helpful, and I encourage inspectors to understand it fully. Any questions?
Yes, we've got a question from Kurt Krasnitzer. Will the regulators Safe Work be policing these new requirements regarding records and documentation?
That's a good question. Across Australia, there are similarities in the legislation. They are not all the same. Each state is different. One state that I do know that demands compliance with 3788 is South Australia. Other states, whilst they may not state it in their legislation, they have it as a code of practice. And the obligation or the expectation of those who do not have it in regulation expect the standard to be complied with. As to the policing of that compliance, that is something I cannot answer. That is a matter for the regulators. My knowledge of recent times is that regulators have enough on their plate without dealing with all of this, and they do not necessarily employ inspectors who are well versed in pressure equipment, boilers and pressure vessels, and so they may or may not have the skill base to be able to police this as a regulatory requirement. But I would still exercise caution because there are insurance implications and other issues from a regulatory point of view. It doesn't matter whether they police it or not. The obligation is on the owner to comply with legislation, and the inspector is just one of those who is engaged by the owner to ensure compliance, that they are meeting their obligations under work health and safety legislation. That's the only way I can answer that one for you today.
And we have another question from Rob just now. Who is typically responsible to nominate the table 4.1 column 1 pressure equipment type?
That is a combination, I would suggest. It's the owner's obligation in addition to advice and direction from the inspector. The inspector is merely to inspect the equipment, and it's an obligation of the owner to ensure that the equipment is inspected and that it is safe to use. That is the terminology from legislation, and that is why the owner is engaging the inspector. I hope I've understood the question correctly. Is that answering the question?
I think so. If it's not, I'm sure Rob will get back to us. But that's it for questions for now. So I'll go to the next slide.
This is the last section in the standard. It's a brand new section, and it is specific equipment inspection requirements. And it references various types of pressure equipment for inspection and covers where the old appendices and additional new requirements for inspection. I found it very educational. It covers quite a lot of detail, which was not previously covered. So again, it's a good bedside reading for any diligent inspector, and it will inform them quite well on inspection requirements. It includes the boilers and a requirement to inspect for compliance with 2593, as we mentioned earlier, as well as NDT of internally fired multi-tubular boiler wells, which was never covered before, and that is new. Various types of corrosion are outlined in this section, and that will assist the inspector. It includes tables as well, so the inspector has a good reference to be able to help them with the inspection. Within this section, there are quite a number of links to various clauses if you're using the digital edition of the standard, and it gives links to the appendices as well for further details. Defects with some pressure equipment are described and aid inspectors to make better decisions. I found this to be very helpful, and I think inspectors will as well. It's good reading. Transportable vessels in particular are detailed and include the need for NDT requirements and acceptance. So that will be very helpful to those who are conducting inspections of transportable vessels. It was generally well covered before, but I think it's made clearer and easier to follow in this section. Heritage boilers, again, it's similar to what was there before. There's not much change in that. Pressure vessels are well covered with good information, historic pressure vessels. There are some very old ones around, and there's a lot of societies who use heritage boilers and pressure equipment as well. NDT is generally very well covered and helps inspectors with better information during the inspection process. Again, qualified people doing NDT requirements are needed. That is essential, and inspectors are not to be doing, excuse me, not to do NDT unless they are suitably qualified to do so. Next, any questions?
Yep, we've got a question from Tony Major, clause 9.2 boilers. This mentions fire tube boilers only. Will this expand to include water tube boilers, specifically the common smaller vertical water tube boilers? The clause refers to part of the boiler shall be subjected to testing and all wells are included. Could you clarify the scope of the testing requirements?
Okay, my understanding of this is that it is purely for IFM or internally fired multi-tubular boilers, fire tube boilers. It is not extended specifically to water tube boilers. Having said that, I would encourage inspectors to carry out NDT in some water tube drums. For example, they might consider longitudinal and circumferential wells in steam drums, mud drums, or any other area that is subject to cyclic stress or other stresses that may cause or initiate cracking in boilers. But at this stage, 3788 does not have the requirement for NDT for it's mandated NDT for water tube boilers, and I believe it's not intended to change that. But my advice is, as an inspector, consider the drums in water tube, specifically large water tube boilers. And I think that is a norm in many cases. And it would also be a norm for remaining life assessment in some cases where there are potential wells that may lead to cracking in some areas in water tube boilers. So the answer is, at the moment, 3788 only mandates wells in fire tube boilers.
And we also had a question submitted earlier last week about clause 9.2 from Frank Bush. So clause 9.2, where it talks about in addition to other additional inspection and checking at intervals not greater than 4 years for fire tube boilers. So it's this clause. And then his question is that the main issues raised with him by operators are the costs of lagging removal and replacement, NDT, loss of production, having to retest welds on a 250 psi boiler when operating at 150 psi.
I fully understand the issue, and I did mention at the beginning of the webinar where this was identified as a significant change, that this would have a major impact and be very controversial. I understand it's similar also for other vessels where the requirement is to remove lagging. It's a big cost. I can't say other than what is required by the standard. I've identified it as a change. It's a mandated change, and I would suggest there may be non-intrusive or techniques that may be considered. Instead of inspecting from the external in, it may be a way to inspect internal to external using non-intrusive techniques. That would be NDT. There may be a way of dealing with that. That would be something that creative inspectors will have to consider. But I can't say other than what the standard requires, which is not greater than 4 years, that the wells are either radiographed, UT'd, or similar, as good as visual, but it does require those tests to be carried out at not greater than 4 years. So it's a 4-yearly inspection, and I think it is quite a big ask of industry to do this. But I think doing the inspection by UT from the internal to the external may address it. Radiographic techniques may address it, using it from the internal to external, but NDT experts would be better advised or best to consult on this, whether it will work or not, to ensure that the wells are compliant. It's never been an issue up until now, and I don't see why it can't be done at greater intervals if it is to be done, or techniques are used that will give a similar result rather than having to do it at a 4-yearly. The time interval may be too short. I don't know. I'm only identifying it as a requirement that must be met. It's an owner's obligation. I can't answer it any better than that, I'm afraid.
Okay, we have a couple more questions. First one is from Prem Kumar Panika, who's asked, appreciate some guidance on recommended practices for inspection of composite materials, say fiberglass material.
Yeah, this is a complicated area. My experience isn't great enough to be able to fully answer that in terms of a technical methodology. But I'm sure experts in this field should be consulted. There's not many in Australia. I do know that I've had to engage myself with experts in this field. It's not a very common one, and it's generally lower pressures that are involved. And the equipment that I have found was compliant with overseas design codes, and the techniques are not understood by me, put it that way. So really, I can't answer it in full as to the techniques to engage other than visual. So you would need to consult with an expert in this type of equipment to be able to find a suitable technique to inspect them adequately for continued service. Sorry about that.
And we have another question from Rob. As an example, what table 4.1 pressure equipment type would be a truck mounted air compressor hazard level C that is not pressurized during transit?
Truck mounted would mean that it's got to be compliant with road rules, Australian design rules, which are covered by a different standard entirely. They're actually rules. It would have to be bolted down, etc., etc., as opposed to a work vehicle that is transporting an air compressed air receiver. If it does not contain gas under pressure or air under pressure, then any vehicle can transport such a, as long as it's suitable for the weight, etc., without going into all the details. Yeah, that's it. Yeah, it's the only way. If it's truck mounted and is under pressure, then it must comply with design rules. If it is not under pressure and it is a work piece of equipment, then it just must be adequately transported and secured as normal for anything else on a truck. That's the only way I can answer that one.
Okay, that's the questions for now. So I'll go to the next slide.
Okay, we had 26 appendices, as I said before at the beginning, and now we only have 4. It is a massive reduction, I think you'll agree. It also cuts down the size of the standard. I think it's by about 40 pages in the standard complete rewrite. The appendices, in my opinion, should be read in conjunction with Section 9 for inspection, because they all relate to Section 9. That is methods of inspection, assessment of damaged pressure equipment, inspection of pressure equipment, and examples of inspection reports. And the only one that is normative is assessment of damaged pressure equipment. Appendix A, C, and D are informative and are a good read and would be advised to be followed by inspectors and inspection bodies, but only is mandated as a normative. Any questions?
We have a question from Abbas Mohammed, not related to this specific slide. In particular with NI inspection and clause 4.3.4 requirements, it is very good to see we have listed the clauses and the points about limitations of NDT, deposit or scale. It's very important that clients are confident about the asset history before the engineers and competent persons can advise UTT in lieu of internals. Your advice or comments, please.
Yes, probably if I go, it doesn't matter. It is good advice, and NII is advised to be used in some cases where it is not appropriate to go into a vessel or there's complications around the vessel for inspection purposes. For example, the electrical pressure equipment, which is now extensively used around Australia, is well benefited from the use of NII, ultrasonics, UTT, etc. for inspection purposes and will, I think, give a good result by using these techniques. I'm not sure I can comment further on anything else. Inspectors themselves may not be knowledgeable enough in some cases for UTT, Ultra NDT, etc., and the best technique to use, and would be advised to consult with either experts or technicians who understand the techniques that would be best engaged to give them a better result, to help them make decisions from the inspection process. They're my only comments at this stage on that.
Okay, so that's the questions.
Okay, methods of inspection covers a wide amount of information for inspection, including testing. And this may help also in answering the previous question in relation to testing techniques. It includes the inspection methods that can be engaged by inspectors, which is very helpful. And also the testing and reporting is very detailed. It's a lot more informative and gives information for testing types. Inspection bodies involved in testing are advised to take note of this appendix. And this actually does, I think, answer some of the question that I've just addressed previous to this slide. So it should hopefully help inspection bodies to get a resolution using NDT techniques and other inspection methods. So any questions in relation to that slide?
No questions at the moment, so I'll go to the next slide.
Now, this is normative, and I think it's fair to say would be expected to be followed. It has a lot of formulae to assist inspectors make calculations, which will give them decision-making skills with relation to the inspection that they are carrying out. And again, it's linked to many sections for those who use the digital edition of the standard. Goes to various sections to help with clarification of some of the clauses. It also addresses flaws, wall thinning, and remaining light, which is important, and again, will greatly help inspectors to do better inspections. And again, the fitness for service is explained as well as simplified fracture mechanics. Most inspectors, I believe, would not do fracture mechanics and would be best to engage an expert in fracture mechanics. Not that there's too many in Australia, but they would be advised to engage somebody who is competent in this area. But again, the inspector will have good knowledge on the concept of fitness for service, in addition to information on fracture mechanics. Stresses on pressure equipment are outlined, and particularly for high stress vessels. This has always been a controversial area. High stress vessels need better techniques by inspectors to carry out their inspections adequately and come up with solutions where there are issues associated with high stress vessels, such as repairs, wall thinning, and so on and so forth. So there's very good information. It is normative, so it's expected to be followed. I think that's fair to say. Any questions?
No questions on Appendix B, so I'll go to the next slide.
Again, this is an informative section, appendix, and it includes inspection of API 620 tanks and equivalent tanks. It covers pressure relief valves. Again, that's something that is quite controversial for some people, but that is spelled out earlier in the standard where the section is on pressure relief devices. It includes inspections of boilers, fired heaters, unfired pressure vessels, and it includes low temperature vessels. And these were previously covered in 2006 under an appendix. It also includes various types of heat exchangers, which inspectors will encounter during their inspection life. Pressure piping, including buried pressure vessels inspection, is included. Previously, that was an appendix for buried or mounted pressure equipment, where cathodic protection was required and so on. Now it's all included in Appendix C. The foundation of pressure equipment is new, and that is required to be inspected by the inspector. Well, it's advised as it's an informative requirement, but I do find it's advisable to follow this and check the foundations for pressure equipment, whether it be metallic or non-metallic. For example, pressure equipment that's mounted on concrete plinths should be inspected. My experience has shown that the plinths over time do deteriorate, and corrosion from reinforcement is exposed and does get damaged, and they crumble and break down. So inspectors would be advised to make sure that they check the foundations of pressure equipment and report on them adequately. In some cases, it's critical. In other cases, it's not so. So it's up to the inspector at the time of inspection to carry out their inspection covering the foundations. Any questions in relation to this one?
No questions on Appendix C so far, so I'll go to the next slide.
Okay. This again is informative, and it covers the inspection reports. It includes recommendations for inclusion in reports. Obviously, each pressure vessel is unique, and there are many, many different types of pressure vessels, fired and unfired, that inspectors will need to report on. So an inspection body, if they're using templates, may need to review what they've got following a read of this section. The equipment is required to be fully identified, and in some cases that has not been done. And sometimes owners will put their own markings on equipment, which inspectors may need to take into account to ensure that they are identified the equipment that they are inspecting. So in full identification will include looking at the documentation, checking the markings and so on, which is addressed earlier in the standard. Then there is the requirement that the equipment is declared safe to operate or disclose any shortfall. In other words, if the equipment is not safe or the equipment requires repair, derating, or some other action that's required by the owner, then the inspector has an obligation to bring that to the owner's attention to restore the equipment to a condition where it is safe to operate and the inspector can report accordingly. I think that covers that one. And again, the inspector, as I say, is required to bring to the attention of the owner a need for repairs. There may be an interim period they may be able to operate whilst the equipment requires repairs, but they may be able to derate. The inspector has the authority to be able to say the vessel requires repairs. They may decide to choose how to repair that vessel, or they may engage competent persons to advise the inspector on a safe method of repair and advise the owner accordingly so that the vessel can be restored to fitness for service and that it's safe to operate. This is new in some respects for inspectors, and some inspection bodies may not like to make the statement that the equipment is safe to operate. It is a legislative requirement, in addition now to 3788 requiring that the equipment is safe to operate before going back into service. Any questions?
Yes, so Abbas Mohammed has asked, can the inspectors recommend if the foundation is damaged?
Most definitely. It would be part of the inspection process, including the foundation. They may determine that the foundation is suitable to continue for a short period of time to allow the owner to budget for a new foundation, or if it is decided by the inspector that it is not suitable to continue in service, then the inspection has determined that it is unsafe to allow a pressure vessel to be operated whilst the foundation is in a defective state. But he can recommend repairs be carried out. He would perhaps consult with an expert or a competent person in the foundations to help him with the inspection, to be able to say to the owner a safe method of repair or a replacement of a foundation, whatever the case may be. But yes, the inspector would be advised to tell the owner and report on the foundation that it is safe to continue or not safe to continue, or there's an interim period until which time the inspector is no longer satisfied that it can continue in service. That answers that one, I hope.
Yes, and no further questions at the moment, so I will go to the next slide.
Okay. There have been some errors identified in the current edition of 3788. If you go, I have noted some of them here for anybody who's interested in making an amendment to their copy of the standard. There's a typo on page 14 where refer to is twice. It should be just refer to, which is a typographical statement. In clause 3.3, there should be reference to Appendix C. That's more a comment. It doesn't do that, but it should. Hazard levels in table 4.1 in item 3.2 should read 100 PV value and not 10. That's an error in the standard as it was published. So just put an extra 0 after the 10 in item 3.2. In Appendix C, 6.4 LP gas storage, there's an incorrect reference. It should be 9.5 and not 9.43. And in clause 8.2.3, requirements are not fully reflected in the example inspection reports in Appendix D. What should happen is Appendix D should be referenced in section 8.2.3 to reference the correct information. And I would state any errors identified should go to Standards Australia for the next edition, which may happen in a year, less than a year's time from now. I'm not privy to know the dates, but there will be a reissue of the standard at some future date, hopefully in the next 12 months. And so any errors that are identified should be brought to Standards Australia attention. And similarly, for any issues associated with the new standard that you believe may not be correct or are unnecessary or should be necessary, whatever the case may be, do bring those to Standards Australia's attention, not to NATA, obviously, and hopefully any questions relating to those clauses in the new standard can be addressed following discussion with the relevant committees to get it resolved. And I think that concludes my observation of 3788 and its application. And I hope that it's beneficial to everybody who's joined the webinar today. And I believe it will be made available at a future date by NATA to go over the webinar again if you wish to do so.
Yeah, that's right. Yeah, it'll be published on the NATA YouTube channel and on the various social media as well. We do have a question from Andrew McGregor. General question re ASIP certification. Why have all references to ASIP been removed in the new version of AS 3788?
Okay. I don't know why they removed it, but I suspect strongly it's because Standards Australia is not in the business of demanding qualifications of individuals to carry out certain functions. And this is typical across many Australian standards where there were requirements for specific qualifications to be held by people in the particular industry in which they were working. I did notice that CBIP was removed because that was an Australian or New Zealand requirement. ASIP was an Australian requirement. But what it does do is expect compliance with the table, the new table for competencies to be assessed. It doesn't say how they will be assessed, but the owner or inspection body will have an obligation to ensure that their inspectors are competent according to the table in 3788 as issued. So whilst they removed ASIP, they have substituted it with a table of competencies that inspectors are required to have as a minimum. I might add that if somebody does have ASIP, it does not mean that they have to be reassessed according to the table in 3788, as I understand it. They are already in the business. They have over 5 years experience, and ASIP will likely have covered all the competencies that are expected to be held by inspectors in the new 3788. I suggest it's moving forward where people are going to use 3788 in its new format, that new inspectors will be required to comply with that. Prior competencies are already recognized, and just as a by the way, ASIP is now the ownership of Weld Australia and is going to go through a whole new process in the near future. I don't know how long that will take. I have been made aware that it is now Weld Australia's property and will change over time. Watch this space.
And we have another question from Masood Rahman, who's asked, is the new version of the standard updated mostly to align with API 510 requirements?
No, it was not designed to meet API requirements. It was upgraded to make the inspection process simpler, clearer, and more easily understood. The standard also incorporated some aspects of ISO 17020, in addition to legislative requirements across Australia. It was well out of date, and many people had put forward suggestions for changes, and those changes were incorporated and brought into the new 3788.
Okay, and we have another question from Ken Siddhartha. If the AS 3788 2024 requires 5 years experience requirement, therefore an ASIP certified inspector may not necessarily automatically meet AS 3788 inspector personnel requirement.
That is correct. That is a question that was asked earlier on during the webinar when I answered the question that accumulatively over a period of time, there may be other experiences that would make a person or identify a person to have 5 years experience in the pressure equipment industry. in other ways that would meet inspection requirements, either under mentoring or other experience in inspection of equipment or manufacture of equipment. That is something perhaps inspectors may, or inspection bodies may need to bring to the attention of Standards Australia. They may want to find alternate methods that inspectors would meet that 5-yearly requirement, or change it to perhaps a shorter period. But that was what the committee ended up with and put into 3788, bearing in mind that standards can change, and any clauses that inspection bodies believe need to be changed should be brought to the attention of Standards Australia.